Oh, what is that? It's enough to put me off my food.
But that's where your food goes, the digestive system.
Oh, right, it's in there. So what exactly is digestion?
Digestion is the process by which food gets broken down into small molecules so that it can be absorbed by the body.
Ah, it must be time for a break and a snack.
You're not supposed to eat them. These are the 7 nutrient groups. How many can you recognise?
That's carbohydrates. And that's protein. Fats. Vitamins and minerals. Well, that's 5, but where are the other 2?
That's water. Last but not least, roughage.
Oh yeah, I always forget about those.
We all need a certain amount of each of these to give us a balanced diet. So no more chocolate bars for you. Now, the food we eat has to be broken up before our bodies can use it.
By our teeth.
Sort of. But the real work comes from the stars of the show, enzymes.
So what are enzymes then?
They're protein molecules which act as biological catalysts.
Oh, catalysts! I remember this from chemistry. They speed up chemical reactions.
That's right. Most chemical reactions in living organisms would happen too slowly without enzymes, every cell in our body. But we're going to limit ourselves to digestion here.
Oh, good.
Now, digestive enzymes help to break down large food molecules, but only 3 of these food groups have large molecules: carbohydrates, proteins, and fats.
So there's one special enzyme which breaks down these 3 food groups.
It's not quite that simple. Each group has its own special enzyme. For instance, carbohydrates are broken down by an enzyme called amylase.
So is that what's happening there then? Those particles are the amylase enzyme breaking down carbohydrate?
Yes, and if we look even closer, we can see that the enzyme molecule fits exactly into a carbohydrate molecule, just like a key in a lock.
Oh yeah. So the carbohydrate molecule breaks down into smaller bits.
That's right. It's converted into simple sugars like glucose so that it can be used by the body easily.
Fine, I got it. So, amylase breaks down carbohydrate. So if I were to eat a slice of bread, it would really get the amylase enzyme going. But what about the enzymes that break down proteins and fats?
Proteins are broken down by an enzyme called protease. These are broken into smaller molecules called amino acids, whilst fats are broken down by an enzyme called lipase, and these are broken down into fatty acids and glycerol.
Right. We know which enzyme does the job and what job it does. But where do these enzymes come from in the first place?
We can see here that all 3 of these are produced in the pancreas, there, and the small intestine, there. But amylase is all over glands, and protease is also produced
in the stomach.
You've got it.
So what happens now?
Well, now that the food molecules are much smaller, they can be absorbed by the blood.
Where does all this activity take place?
In the small intestine, where all our digestive enzymes are present. In fact, your small intestine is an amazing structure.
How so?
Well, it's got muscular tissue all along its length.
What? We've got muscles in our intestine?
Well, the food has to move along somehow. This squeezing action that pushes it along is called peristalsis.
Clever.
And that's not all. The inside of the small intestine is covered with millions and millions of finger-like things called villi.
Ooh, look just like my mum's washing up gloves.
I'm surprised you even know what a pair look like.
Cheeky. So these things, the villi, is what helps us absorb our food?
You've got it. They've got a huge surface area, a very thin layer of cells, and a very good blood supply, which all allow for quick absorption of food.
Hey, that sounds just like the alveoli in the lungs.
Yep, same principles. And after absorption, the blood carries the food to all the cells in the body.
Groovy. I think we need to see the whole process from start to finish, though. Whoa, a great big burger. Getting chewed up. So the amylase enzyme is starting to work already.
And then it's swallowed, so it passes down the esophagus into the stomach, where it's pummeled by the stomach's muscular walls.
And the protease enzyme gets to work, converting proteins, or in this case the meat of the burger, into amino acids. So then passes into the small intestine with all its folds and villi.
And more enzymes.
And more enzymes, before being absorbed into the blood.
Anything that's left moves along to the large intestine, where excess water is absorbed from the food. Then, what's left moves down to the rectum, where feces is stored, ready for expulsion.
Oh no, that's really put me off the food.